Hi, in this section 9.5, we are on page 583. Write that up here. And we're working on factoring trinomials today of the form x squared plus bx plus c. Now, we practiced this with algebra tiles in the previous, I don't want to call it section, but like the introduction to section 9.5. And what we're going to learn today is how we can actually factor these without having to take out algebra tiles and make a rectangle out of it and get that arrangement. There's probably some patterns you might have noticed with the algebra tiles that will apply to today. So to factor this, remember factoring means we need to find what times what will produce this expression. That's factoring. Think about factoring back in 4th grade. You know, if I gave you 30, you could factor 30 into 6 times 5, and you can factor 6 into 2 times 3. So you could break this thing up into 2 times 3 times 5. 2 times 3 times 5 is 30. That's factoring. Well, instead of just factoring a number, we're going to factor a trinomial today. Now, the process for this is pretty easy. How do I actually factor it? It's a simple two-step process, and when the lead coefficient is 1, which in section 9.5, every one of these problems for the most part will have a lead coefficient of 1, then it's a simple two-step process. Here's all we need to do. We have to find the possible factors of c first, and then once we find the possible factors of c, we need to figure out which of those factors have a sum which results in us getting b. Okay, remember sum means adding. Alright, so that's a simple two-step process. The lead coefficient's 1. We're trying to figure out what times what gives us c, and yet those same two numbers have to add up to b. That's what the sum means. So let's actually try that on a few problems. Let's go to number 3 on page 586, and I wrote the problem down up here. And it's x squared plus 4x plus 1, and you notice right now the lead coefficient is 1. So this is a simple two-step process. What are the possible factors of 3? What times what is 3? And this one's pretty easy. There's only two possibilities. 1 times 3 equals 3, but remember, so does negative 1 times negative 3 would equal 3. All right, so there's two possibilities here. And now all I got to ask myself is, which one of these two possibilities will add up to 4? Well, obviously, 1 and 3 add up to 4, not negative 1 and negative 3. Negative 1 and negative 3 add up to negative 4, which isn't helping us. I want positive 4. So 1 and 3 are what I'm looking to use, which means all I need to do, the correct factorization of this would be to say I have x plus 1 and x plus 3. Now let's go back. Remember, you start with x squared, so I know I have to have an x times x somewhere, and then I have a 1 times 3 is 3 and a 1 plus 3 is 4. Let's just make sure we understand why this factors into x plus 1 times x plus 3. Well, I think you understand where I got the 1 and 3 from, but look at what happens if I now double distribute this. Just check out what happens. If I double distribute x times x, let me turn this layer on. X times x is x squared, x times 3 is 3x, 1 times x is 1x, and 1 times 3 is 3. Do you notice how I get x squared plus 4x plus 3, which is exactly what we started with? So that's all we have to do to factor a trinomial when the lead coefficient is a 1. Just ask yourself, well, I know my first term is x times x. All I need to figure out is the two numbers that go here, and I do that by taking what times what is 3, and those same two numbers have to add up to the middle term. In this case, it's 1 and 3, as I just showed you here. Okay, let's try another one. Let's try number 5, and there's the problem. So when I go ahead and factor this, now when I factor it, I already know the answer is going to turn into something like this. It's going to be b and then plus or minus something, b plus or minus something. Because think about it. Isn't b times b when we double distribute b squared to start? So I know it's going to factor into something that looks like this. Here's what we need to do. What are the possible factors of 72? Well, there's a bunch of them. I wrote them all down. 1 times 72 is 72. 2 times 36, 3 times 24, 4 times 18, 6 times 12, 8 times 9. I will tell you right now, if your mental math is weak, it's going to make this a lot tougher to do. You penalize yourself with weak mental math the higher up in math you go. All right? So again, if you have to use a calculator all the time to break all these down, you can do that, but it's taking you more time, which again is shortening up your time on the test, and you're working on basic 6th and 5th grade math to try to figure out what are the factors, okay? So remember, it's not only positive times positive, it's also negative times negative, and I'm trying to figure out which of these factors will also add up to negative 17, and I'm looking and I see right here, negative 8 times negative 972, negative 8 plus negative 9 is negative 17. So I know it's the factors that add up to negative 17 are negative 8 and negative 9, okay? Which means the correct factorization of this is b minus 8, b minus 9, and again, I can prove that to you because if I now double distribute and work this back out, I get b squared minus 9b minus 8b, oops, I meant to say minus 8b, and negative times negative is positive, plus 72. Are you seeing how I'm getting b squared minus 17b plus 72, which is exactly what we started with, okay? But again, if the lead coefficient is 1, it's this easy. Let's do one more. Let's do problem number 9. You notice the lead coefficient's 1 in my trinomial. This should be real easy. What times what is negative 18? What are the factors? Well, negative 1 times 18 or 1 times negative 18 multiplies out to that, or 2 times negative 9, negative 2 times 9, or 3, negative 6, negative 3, 6. Which one of these pairs add up to negative 7? That's the big deal. Well, right now, we can look right now, and if I take 2 plus negative 9, that's going to be negative 7. So I know it's got to be 2 and negative 9. So the correct factorization, again, is y plus 2, y minus 9. Pretty basic. Again, if I double distribute this out, I'll get right back to here. Okay? If you look at a problem like 49, my students always get screwed up with this because they see that we have 1c squared here, so that's easy. So I know that this problem starts off with, when I factor it, I know I have to have c times c. But now we throw the second variable in here and it screws everybody up. This is as easy as what we were just doing. The only difference is, wouldn't d times d, remember when we double distribute at the end we do d times d, wouldn't that give me a d squared? So we just got to set it up like this. All I need to do is figure out the numbers that belong here and I'll have this. So let's work it out. I got to ask myself, what times what is 36? So I'm thinking in my head, well, 1 and 36 would work, 2 and 18, 3 times 12 works. What about 4 times 9? And I'm going to stop there because I immediately notice as I'm multiplying these out, none of these added up to 13 in the middle, but 4 plus 9 is 13 and 4 times 9 is 36. This must be C plus 4D and C plus 9D. And just to prove that, if I double distribute, I'm going to get right back to here. C squared. C times 9D is 9CD. And 4D times C is 4CD. And 4D times 9D is 36D squared. And when I combine like terms, which I'm underlining, there is my 13CD. And can you see how I'm getting right back to where we started? Okay, very simple process. When you solve an equation of the second degree, we have to understand this process because remember, a second degree equation means you have a term to the second power like one of these equations. And we've actually practiced solving these kind of equations already back earlier on in the chapter. Remember, we want to factor and we want to make a product. Because remember, when you have a product, if two things multiplied to give you 0, one of those things have to equal 0. All right? So the key to solving any second degree equation, there's always a pattern to this. If you ever have a second degree equation, you want to always get all terms on one side and have 0 on the other side of the equation, like I have set up here. Every term on one side except for 0. Once you do this, you can factor the equation, and since these factors multiply out to 0, each factor equals 0, or one of these factors would equal 0, giving you 2 easy equations to solve. So each factor you can solve for 0. So let's actually do one like that, like look on page 586, number 20. So the first step is to write an equation, and you notice how my lead coefficient's 1, so we're going to apply what we just learned. My next step, after I write the equation, since it's second degree, make sure all terms are on one side and 0's on the other, and there's a little check mark here because that is the case. And now I want to factor it. So I want to think about what times what is 21 but adds it to negative 10. So as I'm thinking about that, remember, 1 and 21 add up to, or multiply out 3 and 7, and so are the negatives. Right? Negative 1 times negative 21, negative 3 times negative 7. Well, as I do that, I notice right away these multiply out to 21 but add up to negative 10, so there's my factoring. And remember, if this times this gives you 0, one of these two must work out to 0. One of these two things must equal 0. So let's quickly solve. X minus 3 has to work out to 0, or x minus 7 has to work out to 0. I got 2 very simple equations to solve here. Obviously, either x has to be a 3 or x has to be a 7, and we can always check it at the end if we're not sure. Okay, if I plug a 3 in here, think about it. If I plug in 3, we'll just check one of them. 3 squared is 9. 10 minus 3 is 30. Would you agree that 9 minus 30 plus 21 equals 0? If you plug it in your calculator, that's a true statement. All right, so that's how we can solve. Let's do another one. Number 24, this is second degree, so write the equation. First step, it's second degree. I must get everything on one side and 0 on the other. As soon as I see a second degree equation, get all terms on the left, 0 on the right. Okay, now I have to factor this. Do you notice how the lead coefficient is 1 for this trinomial? So all I have to think about is what times what is negative 24, but adds up to 2. Well, in my head, I'm thinking 6 times negative 4 is negative 24, but 6 plus negative 4 is 2. That's working out great. So I have r plus 6, r minus 4. And since these are multiplied together and they're multiplying out to 0, either r plus 6 has to be a 0 or r minus 4 has to be a 0. And I can quickly solve. I didn't show any work here. I figured you can follow me here. If I take away 6 from each side, I get r equals negative 6. If I add 4 to each side, I get r equals 4, and I just solved it, and of course, I should check it. Remember, from earlier in the year, in fact, we started in the end of Chapter 5, early Chapter 6, we were talking about zeros of functions. Remember, a zero of the function means what can you plug in for x to make the function 0? What number will make the whole function work out to 0? So in number 30, when they say to find the 0 of the function, they're asking, if I make y 0, if I make f of x equal to 0, what value for x will make this statement nothing? Well, you see how I have a second degree equation? Make sure all terms are on one side and 0's on the other. Now I should factor it. Since it's second degree and the lead coefficient is 1, this is easy. What times what's 18 but adds up to 11? Well, that's pretty easy, I think. 9 times 2 is 18, and 9 plus 2 is 11. So x plus 9, x plus 2 are the factors. Now remember, I'm multiplying these together. So if I'm multiplying and something times something is 0, remember, one of these have to work out to 0. So that would mean that I have x plus 9 would be a 0, or x plus 2 would have to equal 0. Well, negative 9 or negative 2 are my solutions. Here's another one. F of x equals negative x squared plus 16x minus 28, and I want to find the 0 of the function. So replace f of x with 0. Now remember, in this entire video, the lead coefficient has typically been 1. Well, this time it's not. It's negative 1. I don't want a lead coefficient of -1, I want a lead coefficient of 1. Well, it's very simple to fix this. Just multiply each side of the equation. Just multiply the left side by -1 and multiply the entire right side by -1. Isn't it legal to multiply each side of an equation by the same amount? Well, when you do that, -1 times 0, let me get rid of this, -1 times 0, that gives you 0. And over here, when you multiply everything by -1, it just changes all the signs over. Oops, change all the signs over. Okay, well, since I have a lead coefficient of 1 now, all I have to do is factor, and I got to think, what times what is 28, but adds up to -16? And I'm thinking, let me see, what about -14 times -2? Isn't -14 times -2 28, but -14 plus -2 is -16? Okay, so I just figured out -14, -2 is my factors, and since I'm multiplying, I know that x minus 14 has to equal 0, which means x would have to be a 14, or x minus 2 would have to be 0, which means x equals 2. Okay, one more here to look at. Here in this problem, they give us s times s plus 1 equals 72, and they want us to solve this. Now, the first thing we're going to do is distribute this through, because this is not a second-degree equation. If I distribute it through, I get to here. Now, do you notice how this is now second degree? And if it's second degree, the first step is to get everything on one side and 0 on the other, so I took away 72 from each side to make that happen. Now, do you notice how the lead coefficient's 1? Well, this should be easy now. Since this is a trinomial, 1, 2, 3 terms, what times what's -72, but adds up to 1 in the middle? Well, I know 9 times -8 is -72, and 9 plus -8 is 1. So the factors have to be 9 and 8. So I have s plus 9 and s minus 8 equals 0. And that means one of these have to actually equal 0 if something times something is 0. So s plus 9 is 0, or s minus 8 is 0. And if I take away 9 from each side here, I just figured out that s would be -9. And if I add 8 to each side here, I know that s would equal +8. And those are my solutions, and I can check that, okay? So I think I've covered enough of the video here. If we have questions, we can go over other things in class, but I think that will get us covered as to what we need to do to be able to get this section of homework started. If you have any questions, we can go through those tomorrow.